energy and momentum. If a constant opposing force of 20 newtons suddenly acts on A, find the time it takes to come to rest and the distance through which it moves. Now, we have mass equals 10 kg, velocity is 6 meters per second. So, opposing force is equal to 20 newton. Now, we have to find the kinetic energy. Kinetic energy, Ke, is equal to half mv squared, and that is half times 10 times 36, and that is 36 joules. Sorry, 180 joules. Now, the momentum is mv, mass times velocity, and that will give us 10 times 6, which is 60 newton meter, or kilogram meters per second square. Kilogram meters per second. Newton second. Now, we have to find the time by which it comes to rest. So, what does that mean? It means that our initial momentum, we are given is equal to 60. Final momentum, from what they have told us, is equal to 10 times 0, which is 0. And impulse is equal to final momentum minus initial momentum. And what is our impulse? Minus, because the F is acting against it. So this one is going to be minus 20. Let me make it minus because it's opposite. Okay, let me leave it because it's opposite. That's why it's minus. It's equal to 0 minus 60, and that is minus 60. Therefore, t is equal to minus 60 over minus 20, which is 3 seconds. Fine. We are also asked the time it will take to the distance is removed. Let's relate the kinetic energy and the work done. So what we are now experiencing is the force that is acting against the body. Therefore, Ke, change in Ke will be equal to Fs, and change in Ke is final Ke, final kinetic energy minus initial kinetic energy will be equal to the work done by F, that is minus Fs, because it is working against it. And what is our final kinetic energy? This one is half m times 0 squared. You know, the final velocity is 0, please. And the initial kinetic energy is 180. It's equal to minus 20x. So S will be equal to 180 over 20, and that is 9 meters. So you can use it like this, or you find your velocity, the acceleration, and you can work everything out conveniently. So what I mean is, since you know the velocity, you can use this force to find the acceleration. F equals ma. So you can do that. So in this instance, A is equal to 20 over 10, which is 2. But it's in the opposite direction, so it is minus 2 meters per second squared. So from here, you can find the t. What's our final velocity? U final is 0. V initial is 6. So from this, you can say V final is equal to V initial minus 80. And from there, you can make this from 0 equals to 6 minus, please, it's plus 80, but I'm using 40. Then plus minus 2. So from here, you can see that C is equal to 3. And you can use it again. In V squared equals U squared plus 2AS. And we have seen that A is minus, V final is 0. So this one is 0 equals to, what's that one? 6 squared minus 2 times 2s. So we are going to have s is equal to 36 over 4, which is 9 meters. So you can see, you can do it in two different ways, depending on what comes to your mind. A 4 kilogram ball moving with a velocity of 10 meters per second collides with a 16 kilogram ball moving with a velocity of 4 meters per second in the same direction, in opposite direction. Calculate the velocity of the balls in each case if they collide on impact, and the loss of energy resulting from the impact. Now, let's say we have ball A. Velocity is 4 kilogram. Mass is 4 kilogram. Velocity is 10 meters per second. The ball B, the mass is 16 kg. velocity is 4 meters per second. Now, we are asked for the common velocity if they coalesce and when they move in different directions also. So let's do A for all. A when they move in same direction. So we are using law of conservation of momentum. So FA VA plus MB VB is equal to MA plus MB V. That is, where V is common velocity. Common velocity. Yeah. So what's our MA 4? What's our VA 10? MB 16. VB 4. And what will be the sum? 4 plus 16 V. This one is 14 plus 64 is equal to 20 V. So this is 104 equal to 20 V. So V is 104 over 20. That is 5.2 meters per second. That one got it. Now let's calculate their initial energy. The initial energy before impact. Energy before collision will be half times 4 times 10 squared plus half times 16 times 4 squared. And this one too. This one is 8. So this is going to give me 200 plus 128, and that gives me 328 joules. That is the energy before impact. So now energy after impact. Energy after collision is equal to half times what is the common mass? 20. What is the common velocity? 5.2 squared. And that is 10 times 5.2 squared. That will give me 270.4 joules. And we are asked, in each case, the loss of energy resulting. So loss of energy will be equal to initial energy minus final energy, which is 328 minus 270.4 joules. And that is 328 minus 270.4. That's 57.6 joules. That's 57.6 joules. Now, when they move in opposite direction, moving in opposite direction. So, it will be MA VA minus MB VB will equal to, because it is now, so this one will now be negative. V will now be negative. VB will now be negative. That's why I have to have this. Okay, let me use like this. MAVA plus MVVB. So in this instance now, V is minus 4 meters per second. So I'm going to have 4 times 10 minus 16 times 4 is equal to 4 plus 16 V. So what are you going to have? This is going to be 40 minus 64 is equal to 20 V. So common V, velocity will now be minus 24 over 20, which is 1.2 meters per second. So it will move in the direction of B. So B is moving in this direction now. So it will move in the direction of B. You can see. So it is minus 1.2. That's why it is moving in the direction of B against A. So the combined bodies move in the opposite direction. Now, calculate the velocity in each case, impact, and the loss of energy. We have calculated the initial energy the other time. Is 328 joules. So final energy now will equal to half times 20 times 1.2 squared, and that is 10, and this is 1.44. 14.4 joules. So loss of energy now will be equal to 328 minus 14.4. 328 minus 14.4. and that is 313.6 joules. 313.6 joules. A stationary mass explodes into two parts of mass 4 units and 40 units respectively. If the larger mass has an initial kinetic energy of 100 joules, what is the initial kinetic energy of the smaller mass? We have shown in our notes that in this instance, when there is explosion, kinetic energy is inversely proportional to the mass of the bodies that they exploded into. So what we are now saying is this, that if the larger mass has kinetic energy of 100 joules, that is Ke equals to constant over mass. Therefore, for mass of 40 units, the energy is 100 joules. Therefore, the constant here is 4,000. So, for the smaller units, we are going to have Ke to be equal to C over 4, which is equal to 4,000 over 4, 1,000 plus 1 to 1. And you can do it straight like this. 100 over Ke, or the smaller mass, is equal to the mass, smaller mass over larger mass, proportion, variation. So Ke for the smaller mass is equal to 4,000 over 4, 1,000 joules, which is 1 kilowatt. And for the proving of this, it's in the notes. So refer to the notes. So the proof is in the lecture. So just refer to the lecture. A bullet of mass 10 grams is fired vertically with a velocity of 100 meters per second into a block of wood of mass 190 grams, suspended by a long string above the gun. If the bullet comes to rest in the block, through what height does the block move? So this is what happens. There is a string here. These are the strings, S1, S2. So a bullet is fired like this from a gun. And when it gets to this wood is 190 grams. And the bullet is 10 grams. So they are now asking us, through what height does it move? Let's calculate, because the bullet is embedded in the block of wood. When it gets there, they will now move with common velocity. So let's see. Using law of for collision of body, law of conservation of momentum. Conservation of momentum. So when it moves and gets to this place, we have 0.1 times 100 is equal plus 0.01 times 100 plus 0.19 times 0. Please, I convert to kg, kilogram, is equal to 0.01 plus 0.19. We have V is common velocity. And this one is 1. This one is 0. So this one is 0.2 V. So our V now, common velocity is going to be 1 over 0.2, which is 5 meters per second. 5 meters per second. So from here, we can get the kinetic energy, and then we see what potential energy is converted to. And you can also use our normal equation of motion. Okay, let's use normal equation of motion. So in this instance, final velocity at the greatest height is equal to 0. Therefore, you can now say V squared equals to U squared plus 2AX. In this instance, A is equal to minus G, but it's acting against the velocity. And we can now see 0 is equal to 5 squared minus 2 times 10x. And what does that give us? S, that is the greatest height move, is 5 squared over 20, which is 25 over 20. 1.225 meters. And if we use law of conservation of energy, law of conservation of energy, so the Ke will be equal to Pe at greatest height. Therefore, half n times 5 squared And what's our n? You know it's 0.2 is equal to mgh. So we have half n times 5 squared is equal to m times 10 times h. Where h is the greatest height known. So we are going to have this one cancel. And then h will be equal to 5 squared over 2 times 10, 1.25 meters. So you can see, you can work it in either way. You can consider that it has a velocity of, yes, that's it. And then the A against it is G. A car of mass 1,000 kg moves at a constant speed of 20 meters per second along a horizontal road. Where the frictional force is 200 Newton. Calculate the power developed by the engine. If the car moves up an incline at the same constant speed, calculate the new power developed by the engine. Assume that the frictional force is still 200 Newton and that sin theta equals to 1 over 20. Where theta is the angle of the incline to the horizontal. Now, the question is in two parts. The first part is telling us that the car is moving like this. And then we have frictional force of 200 Newton against the motion. And the velocity is 20 meters per second. The mass is 1,000 kg. Now, from our formula, we know that power is equal to force times velocity. That is the force times velocity. Or force times distance over t. Now the velocity is constant, so we can use this formula straight. Therefore, power developed is equal to 2,000 times 20, which is equal to 200 times 20, 4,000 watts or 4 kilowatts. So 200 Newton times 20 meters per second. So we have 4,000 watts. If the car moves up an incline, so this is what we have now. The car is moving up this incline. Let's use this one to represent the car. Okay? And we have a friction of 200 Newton from the question. And the V, velocity, is still 20 meters per second. We have theta here. Because it is now moving up an incline, we have a component of its weight down. Its weight is mg. And the component of this weight down is mg sin theta. So we don't need to be calculating the perpendicular parts. So total force now. Total force is equal to 1,000 times 10 sin theta plus 200. You remember the frictional force. So and that will be equal to 1,000. That G is 10 times 10 times 1 over 20 plus 200. So this one is 500. That's 500. So the total force is now 700 Newton. So power will now be FV, which is 700 times 20, which is 14,000 watts or 14 kilowatts. So when it is moving up the incline, it requires greater power. But when it is moving on the horizontal, it will be lesser. Sand falls at a rate of 0.15 kg per second onto a conveyor belt, moving horizontally at a constant speed of 2 meters per second. Calculate A, the extra force necessary to maintain the speed. B, rate at which work is done by this force. C, the change in kinetic energy per second of the sand on the belt. Here we have conveyor belt like this, and sand is falling like this at 0.15 kg per second. And the conveyor speed is moving at 2 meters per second. Now, we ask, calculate the extra force necessary to maintain this speed. We know that F is rate of change of momentum. So what is the momentum along this side now? We are going to have N over T times velocity. And that's going to be 0.15 times 2, which is 0.3 Newton. We ask rate at which work is done. At which work is done by this force is going to be FV, which is equal to 0.3 times 2. Because that's the velocity along that direction, which is 0.6 joules per second. 0.6 watts. That's 0.6 watts. Now, see, we have rates the change in kinetic energy per second of the sun on the belt. You know, the sun has Ke per second. It is first of all change from kinetic energy, and on getting here, the whole velocity changes to 0. So we have half m, it changes from here to this, times v squared over c. And this is half times 0.15, yes, this is 0.15 per second, times 2 squared. So this one comes like this, and that is 0.3 watts. So that's what we have. This is the work done by this force, and this is change of the kinetic energy. Because if you change from this kinetic energy, and later this one will now move it away. A railway truck of mass 2 times 10⁵ kg moves at a constant speed of 72 km per hour up a straight incline against a frictional force of 1.28 times 10⁴ Newton. The incline is such that the train rises vertically 1 meter for every 100 meter. 100 meter traveled along the incline. Calculate 1, the rate of increase per second of the potential energy of the train. 2, the necessary power developed by the train. So to calculate, let us bring out some information. Mass is 2 times 10⁵ kg. Velocity is 72 km per hour, which is equal to 72 times 10 over 36 meters per second, 20 meters per second. We are also told that the frictional force is equal to 1.28 times 10⁴ Newton. We are also told that the incline theta, that when this one moves 100 meters in, this one is 1 meter. Therefore, sin theta is equal to 1 over 100. Now, we are now asked the rate of increase per second of the potential energy of the train. From this information, we can see that when it moves 100 meters, this one increases by 1 meter. Therefore, when it moves 20 meters, this one moves by 20 over 100 times 1, which is 0.2 meters. So, which means that per second, increase in height per second is equal to 0.2 meters. So, for us to calculate, therefore, increase in potential energy per second is equal to mgh, which is equal to 2 times 10⁵ times 10, that is g, times 0.2, which is going to give me 4 times 10⁵ joules, or 400 kilojoules per second. So that will be the increase in potential energy per second. Now, the second part says the necessary power developed by the train. The necessary power will be equal to total force, resisting force, times velocity. Now, how do we get total resisting force? We get it like this. This is the train. It has friction of 1.28 times 10⁴ Newton first. At the same time, the component of the weight down, which is mg sin theta. So it's going to be this force. Total resisting force is going to be this one times velocity. So let's calculate total resisting force. Total opposite force. Let me hit opposite force or resisting. A rocket of mass m is moving at constant speed in free space and initially has kinetic energy E. An explosive charge of negligible mass divides it into 3 parts of equal mass m over 3 in such a way that one part moves in the same direction as the parent rocket with kinetic energy E over 3, and the other 2 portions move up at angle 60 degrees to the direction. Determine the total energy W imparted to the parts of the rocket in the explosion. So this is what happens. We have a whole mass rocket moving, and later on it broke up into 3 parts: m over 3, m over 3, m over 3. So with this, we are told that the energy here is E, and the energy here is E over 3. So we know that the motion, on motion, it has an initial kinetic energy, and that is E. Therefore, it must have a velocity. So we call that velocity V. Now, let's call this one V1. This one moves the velocity V2, and this one moves the velocity V3. Let us calculate. We are told that the energy here is 1/3 of the energy here, and this one This one is moving with velocity v. It has initial velocity v. And we know you are given certain condition that this one is also moving with having energy E over 3. So Ke here is E. Therefore, the kinetic energy in this one is E. E is equal to half mv squared. The kinetic energy here is E over 3, which is equal to half m over 3 v2 squared. V2 squared. Since we know that this one and this one, so let's multiply this one by 3. So half m v squared is equal to 3 times half m over 3 v2 squared. So you can see cancel, cancel, cancel. Therefore, v squared is equal to v2 squared. So v is equal to v2. So we can see that this one, the velocity here is equal to the velocity here. That is established now. Now we consider the law of conservation of momentum to know what is the velocity of this one and what is the velocity of this one. We also told that they move in the direction of 60 degrees to the initial direction. By law of conservation of momentum along any direction, momentum before explosion is equal to momentum after explosion. Therefore, the momentum before explosion is mv along horizontal or x direction. Let's call it x direction. Mv is equal to m over 3 v2 plus m over 3 v1 or 60 plus m over 3 v3 plus 60. So this one. And we have established that v2 is equal to v. Therefore, mv is equal to m minus m over 3 v cos 60 is equal to half. So by the time I add this to it, it gives me m over 3 v1 plus v3 half m1 v1. Yes, that's what it's going to give me. But from this, we can see that along the vertical direction, we have 0 here. Therefore, m over 3 v1 sine 60 is minus m over 3 v3 sine 60 equals to 0. Hence, we can see that m over 3 v1 sine 60 is equal to m over 3 v3 sine 60 degrees. This one cancels this. This one cancels this. So v1 is equal to v3. Here we have established that v1 is equal to v3. So we will now impute it here. Therefore, this one will be equal to half n over 3 into 2v1. So this one cancels this. So you can see that this one is going to be 2n over 3v is equal to n over 3v1. So let me cancel this one. So you can see that v1 is equal to 2v is equal to v3. So what I've been able to get now is that the velocities of this part doubles the initial velocity in the horizontal direction. So with this, you can calculate the total kinetic energy after explosion. Let's calculate that. So we have decided that v1 equal to v3 equals to v2, v2 equals to v. Now, we can now say that w equals imparted energy, and energy can neither be created nor destroyed. Therefore, E plus W will give us half n over 3 v1 squared plus half n over 3 v2 squared plus half n over 3 v3 squared. From this place, we discover that E is equal to half m v squared. So we have half m v squared plus W is equal to half m over 3 v1 is 2v, 2v squared plus half m over 3 v squared. This case, you can see v2 is equal to plus half m over 3 v2 2v squared is 2v squared. 2v squared. We have gotten them initially. Then we can continue and say half n v squared plus w is equal to, this one is, so half n over 3 4v squared plus v squared plus 4v squared. So this gives me half m over 3 9v squared. 9v squared. So this one here, this one is 3. So half m v squared plus w will give me 3 over 2 m v squared. So w is equal to 3 over 2 minus half m v squared, which is m v squared, which is 2 times half m v squared, and this is 2e. Therefore, the energy imparted is equal to 2e, 2 times of the initial kinetic energy of the rockets. In the diagram, two trolleys P and Q of masses 0.5 kg and kilogram and 0.30 kilogram respectively are held together on a horizontal track against a spring which is in a state of compression. When the spring is released, the trolley separates freely and P moves to the left with an initial velocity of 6 meters per second. Calculate A, the initial velocity of Q, B, the initial total energy of the system. Calculate also the initial velocity of Q if trolley P is held still when the spring under the same compression as before is released. So what do we have here now? We are going to use law of conservation of momentum, at the same time law of conservation of energy. Now this system now is just like explosion. So which means that initial momentum is 0. Initial momentum is 0. Then look at it. Initial momentum equals to 0.5 times 0 plus 0.3 times 0. That's 0. So it should be equal to final velocity. You will realize that this one goes to the left, so this one too will go to the left, to the right. So if you take this one as positive, we take this one as negative. So we have 0.3, and we are told that so P moves to the left with velocity 6 meters per second. So let's give this one V minus 0.5, because it moves to the left. We take this as positive direction. 0.5 times 6 is equal to this one now. 0. This is the final momentum. Final is equal to the initial. Therefore, 0.3 V is equal to 0.5 times 6. So V is equal to 0.5 times 6 over 0.3. So that is 10 meters per second. So 10 times 0.5. So V, initial velocity of Q, is 0.10 is 10 meters per second. Initial velocity of Q is 10 meters per second in the right direction. Now, we also asked to calculate the initial total kinetic energy of the system. So, initial total KE is equal to half times 0.5 times 6 squared plus half times 0.3 times 10 squared, and is equal to this one will be equal to 9 plus this one is going to be 30 over 2 plus 15. So it's equal to 24 joules. So the initial kinetic energy is 24. We are now asked to calculate the initial velocity of Q if trolley P is held down. What does that mean? It means that all the energy here will enter Q. All the energy will be used by Q. And you know that this KE is equal to half mv squared. So this V now, which should be equal to 24. So all this energy is converted into the 0.3 mass. So we are going to have 24 to be equal to half times 0.3 times V squared is equal to 24 times 2 divided by 0.3 square root. And that's giving me 380 square root of 160. And that is 12.65 meters per second. So you can see the constant force resisting the motion of a car of mass 1,500 kg is equal to 1/15 of its weight If we're traveling at 48 kilometers per hour, the car is brought to rest in a distance of 50 meters by applying brakes. Find the additional retarding force due to brakes and the heat developed in the brakes. Now we have this information. Mass is equal to 1,500 kg. So weight is equal to 15,000. Resistive force is equal to this one over 15, that is 1,000 Newton. We are now told that the velocity v is equal to 48 kilometers per hour, which is equal to 48 times 10 over 36. So that is 40 over 3 meters per second. We are also told that due to the brake now, let's call the brake force, braking force, BR, braking force, that it came to standstill after 50 meters journey. So distance equals 50 meters. So we can use work energy relationship, or we can use our normal motion equation. Let's use our motion equation. Let's call total force resisting motion. Let's call it R, which is equal to FR plus BR. That is braking force and frictional force, whatever. And we know that U, initial velocity is 40 meters per second, 40 over 3 meters per second. Final V is equal to 0. Now A, we use this one, we use A to get this one. A is what we are trying to find. Therefore, V squared equals U squared plus 2AS. So we know that our V squared is 0. Therefore, 40 over 3 squared minus, because this one, okay, plus, let me leave it like that, plus 2 times A times 50. So we have 40 squared over 300 is equal to A. Sorry, over 900, because this one is squared too. 40 squared over 900 is equal to 8. And that is minus 40 squared over 900 is equal to 8. So we have minus 16 over 9 is equal to 8. So our retarding force, total retarding force now, R will be equal to 16 over 9 times N, from equation F equals NA, which will be equal to 16 over 9 times 1,500. You can see times 1,500. So we are going to have, let me try to cut it, 3 here, 500. So it's going to be 8,000 over 3. Now, for us to find our braking force now, we know that this R is equal to this one. So, and we know our F here is 1. Therefore, R is equal to BR plus FR, which is BR plus 1,000. So, BR, braking force, is equal to 8,000 over 3 minus 1,000, which is equal to 5,000 over 3 Newton. So it is equal to 5,000 over 3 Newton. So we are able to get our braking force now. BR is 5,000 over 3. And we can see that as 1670 Newton approximately. Now we also asked to find another quantity, which is the heat developed in the brakes. The heat developed in the brakes will be equal to this force times this distance. And heat developed in the brake will be equal to work done due to brake, and that will be equal to Fs, which is 5,000 over 3 times 50. That is the distance the car moved through, and that is going to give us 250,000 over 3, and that is 8,000 3 something. Let me think. 25000. That's 83,333. 83,333 joules, or 83.333 joules. So that is the work done. That is the heat developed in the brake. A bullet of mass 10 grams traveling horizontally with a velocity of 300 meters per second strikes a wood of mass 290 grams, which rests on a rough horizontal floor. After impact, the block and bullet move together and come to rest when the block has traveled a distance of 15 meters. Calculate the coefficient of sliding friction between the block and the floor. So we have a situation of body moving and then joining another body to move together. So what are we going to do now? Due to law of conservation of momentum, we realize that 10 grams converted to kg moves with 300 meters per second plus 290 times 0, because that's at rest, will be equal to 10 plus 290 over 1000 v, because they join together. So momentum before impact and after, momentum after. So what do we have here? We have 3000 over 1000 is equal to 300 over 1000 v. So dividing both sides by 300, v is equal to 10 meters per second. So what does that mean? It means that when the bullets enter the wood, they move together with common velocity of 10 meters per second. Now we are now told that they now move for 50 meters. That you now calculate the coefficient of sliding friction. Before you can do that, let's calculate the opposing force to their motion, which is the frictional force. So that will be frictional force and times distance will be equal to half mv times 10 squared. That is the total energy lost due to the energy lost due to friction will be equal to Fr times d. Total energy lost after body comes to rest will be equal to initial Ke, and that's what I just done here. This is the initial Ke, this is the energy loss. So what do we have now? D is 50 meters, so Fr is equal to half times 300 times half times 300 over 1000, please, over 1000 times 100 over 15. I think that's 15. So what does that give me? This one here is 10. What's again? 2 yarn is 150. So the frictional force is 1 Newton. And the coefficient of friction is the frictional force over the weight, normal force. So mu, that is coefficient of friction. Mu is equal to Fr over weight, and that is 1 over, what is the total weight? 0.3 times 10, which is 1 over 3. That is the coefficient of friction. Sand is deposited at a uniform rate of 20 kg per second and with negligible kinetic energy onto an empty conveyor belt moving horizontally at a constant speed of 10 meters per minute. Find A, the force required to maintain constant velocity. B, the power required to maintain constant velocity. C, the rate of change of kinetic energy of the moving sand. Now, we know some information that the rate, let's draw this in the conveyor belt, and the sand is coming here, 20 kilograms per second, and this one is moving at 10 meters per minute. So we can calculate this one to be 10 over 60 meters per second. We are now asked to find the force required to maintain constant velocity. When this one moves from up down, the same with negligible kinetic energy. So it's just like it is pouring straight on it. The force is changing momentum, and the momentum is from this place to this place. So let's say initial horizontal sand velocity is equal to 0. final horizontal sand velocity is equal to 10 over 60 meters per second. So change in horizontal momentum will be equal to n into 10 over 60 minus 0. You can see. And what's it called? Force is equal to change in momentum over time. And you can see that we have m per time. And we have, so we can say it is going to be mass over time times change in velocity. So which is going to be 20 over 1 times 10 over 60. So I have here 3. So it's going to be 10 over 3 Newton. So that's 10 over 3 Newton. Now we have to find the power required to maintain constant velocity. In this case we have found the force. And power equals force times velocity, or force times change in distance per second. So we also say it is work per second. So here we know our force to be 10 over 3 and our velocity to be 10 over 60, and I'm going to have 100 over 180. So 5, 9. Yeah. So that is 5 over 9 watts. That's 5 over 9 watts. So the last part is asking for the rate of change of kinetic energy of the moving sand. So KE per second is going to be half times mass per second times v squared, and that's going to be half times 20 times what is our velocity? 10 over 60 squared. And this is this. So this is 10. So it's going to be 10 over 36, which is 5 over 18 joules per second. So you can see a meter rule is found to balance at the 48 centimeter mark. When a body of mass 60 grams is suspended at the 6 centimeter mark, the balance point is found to be at 30 centimeter mark. Calculate the mass of the meter rule. 2. The distance of the balance point from the zero end if the body moves to the 13 centimeter mark. So this is very simple. We are told that the center of gravity is 48 cm mark, and the mass we don't know. We are told that when 60 grams is at, let's make like this. When 60 grams is at mark 6, it balances at 30 cm mark. So this is 48. Now, from the principle of moments to balance, clockwise movement will be equal to anti-clockwise moments. So from here to here is 20. Okay. So this moment here is equal to 60 over 1000 times g into 30 minus 6 over 100. Because I want to work everything in SI units. Is equal to mg times 48 minus 30 meters. So I can work like this. I can say 60. Let's cancel this. 60 times 24 over 100 over 1000 is equal to m into 18 over 100. Let's call this. Now m will be equal to 60 times 24 over 18 times 1000. And 6 here, 3. 6 here, 10. So I have 80 over 1000 kilograms, which is equal to 80 grams. Now, we are also told again that when this body, we have known the mass now, is moved to another place, the balance point changes. So we are told that this one moves to 13. What points will this one balance? This one still remains, and we have 80 grams in 80. So this one balances at 30, and this one is moved to 13 cm mark. Yes. So for us to work it out now, so we have to find the new points at which the pivot will balance if the body is moved to 13 centimeter mark. And let's call this balance point B. B. That will be the distance of balance point from origin. So let's take the moment again. B minus 13 over 100 times 60G over 1000. This one will be anti-clockwise. Clockwise. Will be equal to 48 minus B over 100 times 80G over 1000. So let me cut the ones I can cut. 3, 4. So 3B minus 39 is equal to 192 minus 4B. So 7B is equal to 231. So B will be equal to 231 over 7, and that is 33 cm mark. So the new balance point for the pivots is 33 cm mark. A uniform beam 6 meters long and weighing 4 kg rests on two supports at P and Q, placed left and right 1 meter from each end of the beam. Weight of one of mass 10 kg and 8 kg are placed near P and Q respectively, one each end of the beam. Calculate the reactions at P and Q. So what do we have? We have something like this, and we are told it is 6. So we have Q here, and we have P here. So from here to here is 1 meter, and from here to here is 1 meter, and it is uniform. So at 0.3 meter, we have 4G down, and we also have this place to this place 2 meter. And we are told that weight of mass 10 kg and 8 kg are placed near P and Q, respectively, one end of the beam each. So we have the one near P is 10 kg, and one here is 8 kg. So we are now asked to calculate the reactions at P and Q. This is very easy if we take the moment about P or about Q. And we also know that under equilibrium, the total weight down is equal to the total weight force up. So let me make this one G. Acceleration due to gravity. Acceleration due to gravity. So let's take moment about P. Moment about P is equal to 0. Therefore, clockwise moment is equal to anti-clockwise moment. Then, about P, I have 10G times 1. That is the anti-clockwise moment. 10G times 1 plus Q times 4. You can see Q times 4 is equal to 4G times 2 plus 8G times 5. From this place to this place is 5. So I can say that this one is 48G. That one is 48G. This one is 8. This one is 48G. Therefore, 4Q is equal to 48G minus 10G, which is 38G. And you know G is acceleration due to gravity. So Q is equal to 38 over 4 times 10. And that is going to be 9. Now, under equilibrium, the total vertical force is equal to 0. That is, downward force is equal to upward force. Downward force equal to upward force. So, total downward force is equal to Q is 95. So, total downward force is equal to 10G plus 4G plus 8G is equal to P plus 95, and this is 22G, that is 220 minus 95 is equal to P. So P will be equal to 125 newtons. So that's the value for P. A uniform pole 7 meters long and weighing 10 kilograms is supported by a boy 2 meters from one end and a man 3 meters from the other end. At what point must a 20 kilogram weight be attached so that the man will support twice as much weight as the boy? We have a situation here a pole 7 meter long. I was told that the boy supported at 2 meter from here. Let's call this B. And the man 3 meter from the other end. N. And the weight is 10 kilograms. So that one will be at 3.5. This place to this place. So it means that this one is 4.4. This is 2. This is 3.5. And it's weighing 10 kilograms. Let me make it 10 G Newton. And at what point must a 20 kilogram weight be attached so that the man will support 3 times? So what they are telling us that the force here should be 3 times the force here. Let's call this B. M equals 3B. So we are looking for where 20 kilogram weight will be, so that this one will be equal to 3 of this. 3, this one will be 3 of this. Now, we know that total downward force is equal to total upward force. So what is total downward force? That is 10 plus 20 G. This is 30 G. And we know that this one, please, will be X. The distance of the 20 gram from the end will be X. Now, we have, so B plus 3B, which is equal to 4B. So you can see that B is equal to 300 over 4, which is 75 Newton. So now, that is about B. About B. So, what am I going to have? 3 times 75 times, because distance from here to here is 4. 2, no. This one is 2, sorry. It's 2. Because from here to here will be 2. Which will be equal to 100 times 3.5. 1.5. That is 3.5 minus 2. 1.5. Plus 200 into x minus 2. So what do I have here now? I have, this one is 150. 450 is equal to 150 plus 200x minus 400. So what does that give me? So 700 is equal to 200x. X is equal to 700 over 200, which is equal to 3.5 meter points. So it means that it passes through the center of gravity. You can also take the moment about this place, and it will give you the same answer. So now, taking moments about the origin, A, it will be 2, 750, that is anti-clockwise, 750 times 2 plus 3 times 750. This place will be 4 times 4 will be equal to 100 times 3.5 plus 200 times x. So you can see straight, I don't need to subtract 2 this time. So this one is giving me 150 plus, this is 300, 900 is equal to 350 plus 200x. If I bring this one here now, this one will be minus 200 plus 900, that's 700 is equal to 200x. So x will be equal to 700 over 200, which is 3.5 meter mark. So you can see, since it is in equilibrium, taking moment about any points here will be 0. Find the position of the CG of the lamina ABCDEF made from thin sheet metal as in figure. This is the figure. If the lamina is suspended freely from F, what angle will AF make with the vertical? What horizontal force applied at A will maintain the lamina in equilibrium when suspended from F with AF vertical? So we can see, you can find the what's it called, the CG about AF and about AB. So let's call this Y, let's call this X. So, and for us to do that, it will be easy if you can break this one into two like this, or you break it like this, or this one is the easiest way. This is the easiest way. Anyone, you can break it like this, you can break it like this, in any shape you like, yes, anyone. Now, we can use the area to find the center, and we break it into, let's call this A, let's call this B. This is A, area. The center of gravity for the area, and the moment about about X or Y. So let's find the CG Y and CG X, CG Y and CG X, X, and then the moment about X and the moment about Y. So that will make it straightforward once and for all. So let's quickly check. Area for A is, this one is 4, this one is 8, this one is 6. So area for A is 64. Area for B is 48. So the CG along this place for this one, B is 0, is 8. For this one along this place is 2. This one now, for B, the CG about this from this place is 3. From this place, you can see this place is 4 plus 4, 8. Please note, from this point, the CG is A, it is 4 from here. So we are from this place to this place is 4. So we now calculate by adding to this one. That's why I got 8. Now, the moment about X, the moment about this place, we make this one times the distance along the Y. So this one is 64 times 8. And this one is 48 times 3. This one is 64 times 2. And this one is 48 times 8. So the total, we get the sum of this one and this one. So let's see, this one is going to be 2, 1, 1, 2. So we won't be able to get this one until we get this one. So let's quickly calculate this part. So with this, we can be able to get our CG along the y-axis and our CG along the x-axis. So for CG along the y-axis, CG1, it will be 656 over 112. And CG is equal to 512 over 112. Let's calculate. So you can see. So along y-axis, I'm going to have, okay, along x-axis, I'm going to get it at 4.5714. And along y-axis is 5.857. All in CN. You can see now. About x give me y, about y give me x. Now, we also asked another question. That what angle will AF make with the vertical if the lamina is suspended from F? So, it is very easy. Let's just look at it here. You see? So, let's find this angle. Let's find this angle. What happens is this. The lamina will fall like this. Because it must pass through the CG like this. So it will pass through like this. So this is the angle we are looking for, theta. And since I know this place and I know this place, I will get this one by subtracting this from this and this. So with that I can use tan. So let's look theta. This one is theta. Like this one. So theta, arc tan theta, sorry, is equal to arc tan. This one is the opposite and this is the adjacent. So 4.5714 over 16 minus 5.857. So theta is equal to, let me find it, 4.5714 divided by 16 minus 5.857. And that is 24.26 degrees. So you can see, this is how it will fall. So by knowing the angle from this place to the CG CG, you go to get this answer straight. That's what they are asking for. Nothing more. So we are asked the force that will be applied at this place to make it perpendicular like this. The force that we apply at this place to make it perpendicular like this. Let's call that one Q. So I can call this as a ratio of 0.8 kilogram. This part is 64, this part is 48. And so 8, I can break it in this ratio, find the moment, and then use this one against it. Let's see how that one goes. So from here to here, the ratio is 64 to 48. So if I add these two, I got 1, 1. So this place is 64 over 112 times 0.8 G. And this place is 48 times 0.8 G over 112. So I can use that one to find the value of Q. Let's see. So Q times 16 will be equal to, this one is anti-clockwise. So the clockwise will now be, the distance from here to here is equal to 2. The center here is 2. So 2 times 64 over 112 times 8, 0.8 G, plus 48 over 112 times 8 times the distance here is 8. You can see. So Q, 16Q will be equal to 64 times 16 over 112 plus 48 times 64 over 112. So Q will be 64 times 16 over 112 times 16 plus 48 times 64 over 112 times 16. So if I cut this one cancels this one here, this one is 3. So I have 4 times 64 over 112. On adding this one, and that is giving me 4 times 64 divided by 112. So that is 2.286 Newton. 2.286 Newton. So now that I have known the distance of the CG here, I just make the 0.8 G pass through this place, and the Q will be like this. So, or 16Q is equal to 0.8 G times 4.5714. 4.5714. So Q is equal to 0.8 times 10 times 4.5714 over 16. And let's see. So this one will be 2. And so 4.5714 divided by 2. And that is 2.2857 Newton. So you can see it's the same thing. So since I just did this in case you have not gotten the center CG before. So this one is a quicker way to get the answer. A square template of side 120mm has a hole of radius 40mm bored in it. The center of the hole lies on the diagonal and is 40mm from the center of the square. Find the position of the CG of the remainder. Now from the question, we have an understanding of the diagram like this. We have the square. Let's say A, B. Okay, let me do like this. A, B, C, D. Now, there is that. Let's cut this one into 2. We have half like that. Now, we have another diagonal like this. And we are told that the center of a hole is 40 mm from the center of the square. And that hole is 40 mm in radius. So which means that the radius is like this, and it's touching this place. And we have it like this. So this one is 40 mm. And this one is 120 mm. 120 mm. We are now asked to find the position of the CG of the remainder along this place. Since it's a square, we can find it straight. Now, let's break it into 2. This one is bored, so we are going to subtract this one. So we have, let's break it. The distance of this place to this place, we will get it. What is the distance of this place to this place? It is going to be, this is 60 mm, and this one is 60 mm. So this one is square root of 2 times 60 squared. So that's what this place will be. And the distance here will be this one plus 40 mm. So we have gotten our problem solved. So let's break it into 2. We have square, circle, area. Let's find the area. What is the area of the square? 120 mm. This one is 120 mm squared. What is the area of the circle? pi 40 squared. And what will be the total? It will be 120 squared minus pi 40 squared. You can see because the thing is bored out of it. Now, let us find the CG. The CG. The CG is from here 60 root 2 mm. And for this one, it is going to be 40 plus 60 root 2. Are you getting it? 40 plus 60 root 2. Now, let's find the moment about D. Moment about D. Moments about D. And that's going to be 120 squared times 60 root 2. For circle now, I'm going to have pi 40 squared pi into 40 plus 60 root 2. So I'm going to subtract this one from this one. So let's see what it will give me. So let me just leave it here. So this CG for the figure will be 120 squared. Let me call this one FA MB. So it's going to be FA minus MB. Please, just for the space. So I have 120 squared minus times 60 root 2 minus 40 squared pi into 40 plus 60 root 2 divided by 120 squared minus pi 40 squared. So let's see what that will give us. So after solving this, I was able to get 63.4 mm along the diagonal. As we have seen that this one is right isosceles triangle, so this place is 45 degrees. This is 120, this is 120. So you can know the point along the x and along the y direction. So x is equal to y from point D, and that will be equal to this one sine 45. So 63.4 sine 45, and it will be equal to 44.83 mm along this place and along that place. A hollow metal cylinder 2 meters tall has a base of diameter 35 cm and is filled with water to a height of 1 meter or 50 cm. Calculate the distance of the center of gravity in meter from the base in each case if the cylinder has no top. Metal weighs 20 kg per meter square of surface. Assume pi equals 22/7. So we have a situation like this. And no cover. And it's filled with water to the 1 meter height. So the hole is 2 meters. Now let's find the area from the value of the mass for the base, for the curved surface area, and the water. So mass of base is equal to area times mass per kg, and that will be equal to area of the base is pi d squared over 4, and we are told that d is 35 cm, which is 0.35 cm meter. Sorry, 0.35 meter. That is the d. And for the water initial stage, you are told that this one is 1 meter. So let's go on. Mass of the base is equal to this one times 20. This one. So this is pi times, okay, let me leave it, pi d squared times 5. Let me leave it like that, please. Later we'll be putting the figure. So the surface, the curved surface mass is equal to 2 pi d over 2 h times mass per kg, and that is going to give me this one. You cancel this. That is pi d. You know, pi d, and what is our height? 2. What is our mass per kg? Times 20. And that is 40 by D. The mass of water up to 1 meter is equal to pi d square over 4. What is our height? 1. For this pi d square, pi r square height times the density of water is 1000 kg per meter cube. That's the density. So we are going to have, this one is going to be 250. So which is 250 pi d squared. So let's make a table for ease. Now, let's take the moments about the base of these masses so that we can get the height. So, moment of different masses about this over total mass will give us the CG, the center of gravity. So, and that is going to give us this one for the base is 0. So that is pi d squared times pi times 0. For the curved surface, the CG is 1. So that's going to be 40 pi d times 1. For the water, the CG for the water is 0.5, and that will be equal to 250 pi d squared times 0.5 over the total mass. And what does that give me? Pi d squared, 5 pi d squared plus 40 pi d plus 250 pi d squared. And what does that give? Let me first of all cancel what I can cancel. So, pi d pi. So, this gives me, this is 0, 40 plus 125 d over 5d plus 40 plus 250d. And let's work that out with my calculator. Remember, d is equal to 0.35 meters. So, you can see it's 83.75 over 129.3.25, and that is the answer. Now, we are asked if it is filled up to 0.5 meters, that is 50 cm. 0.5 meters. So the CG now will be equal to 0.25 meters. Order remains the same. So we are going to get the value here. This one will change, and this one too will change. Now let me do that because I'm using board. It's very easy for me. So pi d raised to power 4. This one, okay, this one remains times 0.5 times 1000. So this one is going to change. This will be 4 in 1000. This 125 pi d squared instead of 250. So these ones will now change now. This one will become 125 pi d squared times 0.25. Please take notes. This one too will change to 125. So I divided 2 by pi d the other side. So let me do that now again. And let me work it out. So this will be equal to 40 plus 125 times 0.25, that is 3. Okay, let me just put it times 0.25 divided by 5d plus 40 plus 125d, and then you calculate. So you can see I have worked it out, and the answer is 0.6 meters this time around. When it was filled to 1 meter, it was 0.65 meters.